Wait.
Okay, so we're going to talk about congruent triangle proofs. This is some extra practice. If you printed the worksheet, don't worry about number 3 that has a few mistakes on it. There's something that just skips a bunch of steps and it's too much, so don't worry about that. We're just going to do 1 and 2. So take a look at this. Alright, so our given is line AC is perpendicular to line DB. So we know, since AC is perpendicular to DB, this is a right angle. EF is perpendicular to DB. So we know EF, DB, this is also a right angle, because the definition of a perpendicular line, which means it forms a right angle. We know line AC is congruent to line EF, so AC is congruent to EF, and we know angle A is congruent to angle E. Alright, so that's our given. Angle A is congruent to angle E. That looks like a right angle, it's not supposed to be. Angle E. Alright, so angle 1 and angle 2 are right angles. We talked about that. That's the definition of perpendicular lines. Okay, that's the perpendicular symbol right there. Right angles are congruent. All right angles are congruent, right? So we know that angle 1 is congruent to angle 2. Finally, we can say that triangle, so here we go, angle 1 is congruent to angle 2. Finally, we can say that triangle ABC is congruent to triangle DEF because of angle, side, angle, because of that postulate. Alright, do you see how we got that? Finally, we're using this CP-CTC theorem that we talked about a few days ago, I think. Corresponding parts of congruent triangles are congruent, okay? So we're just trying to prove that angle B is congruent to angle D. Angle B is congruent to angle D. So because these triangles are congruent, all the angles must be congruent, so these angles have to be congruent to one another. Alright, I hope you guys get that. So we're going to go on to number 2. Alright, number 2. So given line BC is congruent to line CD, so BC is congruent to CD, AC bisects angle BCD. Alright, those are our givens. So since AC bisects this angle, these have to be congruent, right? Because the definition of a bisector is it divides the angle in half. So angle 1 is congruent to angle 2 because of the definition of an angle bisector, like we just talked about. We're told the next one is the reflexive property. So since these two triangles share a side, this side is congruent to itself for both triangles. So AC in both triangles is congruent to itself. And that's the reflexive property of congruence. That should be written, of congruence, not of equality, or not this time it's not of equality. Finally, we're getting what we're trying to prove, which is triangle ABC is congruent to triangle ADC, and this is by side, angle, side, that postulate. So, this concludes our video. If you have any additional questions, you can come talk to me at any point, and good luck.